Question 5. Which of the following has the smallest probability? The probability that z is greater than 2 in a standard normal distribution, the probability that t is greater than 2 in a t-distribution with 3 degrees of freedom, the probability that t is less than 2 in a t-distribution with 5 degrees of freedom, and so on. You can read the rest. I don't need to do that for you. It's kind of helpful in this problem to visualize a normal distribution versus a t-distribution. So let me remind you again kind of what's going on with those. Um, Let me do a little split screen here. All right, so let me hide the t-distribution for a minute. You can actually calculate the probability of, you can use normal CDF to do these and TCDF. So the probability that z is greater than 2 in a standard normal distribution, I make my minimum 2 and my maximum 1.96, then I'm going to get a probability, not, sorry, not 1.96. If I just delete that and make that infinity, I'm going to get a probability of about 2.27%. Now let's compare that to the probability that t is greater than 2 with 3 degrees of freedom. So if I go to 3 degrees of freedom, that means my sample size is going to be 4. And if I do all the same, if I do my minimum of 2 and my maximum of infinity, I'm going to get a probability bigger. It's going to be about 0.0696. And that's because the smaller the sample size, the more width you're going to have out the outside. So if you look at that t-distribution, you can see it's wider over here. So it's just covering more of the area. So you can conceptually think about it, that a normal distribution is always going to have less of that in the tails than the t-distribution. But if you want to just kind of use your calculator to get these values, it's no problem doing that. Let's kind of explore how you would do that. So what I would do on this problem is I would go into my normal CDF, my TCDF, and just calculate these numbers. So I'm going to do second vars, normal CDF. That's going to be option 2. Now I'm going to make my lower bound 2 and my upper bound infinity. And the standard normal distribution means 0 and 1 are your mean and standard deviation. You can see that 2.275%. And then if I go to option B, actually, let me go to option C for a minute. T is greater than 2 in a T distribution with 3 degrees of freedom. So that's going to be a TCDF. That's going to be second var 6. My lower bound is going to be 2. My upper bound is going to be infinity. My DF is going to be 3. And you can see that 6.9%. So that's definitely a larger one. And we can actually do all of these this way. So I can do option E, the T is less than 2, second vars TCDF. Now less than 2 means that I'm going to go from negative infinity to 2 with 5 degrees of freedom. Well, that's a lot. And let's look at the graph to see why. I mean, think about where the center is, right? You're going less than 2. 2's above 0. So you're shading most of this. So you're going to get 93% with 5 degrees of freedom with going T is less than 2. So that's the idea here, and we can go through and just get the other two. Actually, 94.9%. So this one's going to be a normal CDF. Z is normal. So second vars, option 2. Z is less than 2, so I want to do negative infinity to 2. Keep it at 0 and 1. And you're going to get 97.7%. And then finally, you can do T is greater than 2. So second vars T CDF, 2 and infinity. But it's going to have 5 degrees of freedom. So you can get all your probabilities here, and you can see the one that's going to be the smallest is going to be this one, the normal CDF, where you're going above 2. So that's going to be option A. Now, I would not write work down normally for this, so just go back and rewind and watch what I did in the calculators to get how the inputs would lie, and then you can get your answer.